let's move on to the real subject of today, which is um, direction. Direction is easy. Look, there it is. There. I point, right? And I have direction, right? We're done. That was it. See how easy it was? So how did this subject come about? Well, we have a couple guys that question this. And this is what I put on the last couple times, and that's the universal movie. And why is this movie interesting or important as a tool? Remember, it's a tool, okay? And what it is God stops the universe. He stops the watch, the clock, the universal clock, or the heavenly clock, or the universe just stops on its own, okay? Nothing moves anymore, not even an electron. So everything stops, all motion stops, okay? That's the situation here. And it's a good tool because then we can find out what actually exists. And what exists can be shown in a single frame of that movie. That should show us what exists in the universe. If we had God's eyes, we would be able to see everything that actually exists, right? And that's the idea here, is to visualize, like if we had God's eyes, what actually exists out there. For that, we don't need any motion. We don't need two or more frames of the universal movie. We just need one slice of time, or cross-section of time, as I call it, or no motion, any way you want to visualize or imagine it. We stop motion in the universe, no more motion, no more time. Whatever's there is what exists. You're supposed to visualize a static universe, or what I call a frozen universe. Okay, that's the idea, the tool that I call the universal movie. Okay, so one fellow says the following. He says, explain this mechanism with a paused movie. Well, the issue is that it's a tool. That's all it is. There's nothing to explain. It's just, I want you to make believe, what do you call it? Thought experiment? Make believe, go through the motions of believing that you can stop the universe. Everything in the universe is standing still. Nothing moves. Try to visualize what is in there. Not only the visible stuff, but also the invisible stuff. Remember, you got God's eyes. Okay, what do you think is out there that you cannot see or touch? Okay, that's the idea behind the universal movie tool. Okay, and another fellow says, so does Bill think an instant or durationless moment universal frame is a coherent notion? And again, it's just a tool. It's used to identify what the objects that are there are. What is out there. Okay, and part of the reason is because of this. Let me show you this. Part of the reason is this, or the purpose, right, is that a lot of people confuse static with dynamic concepts. They bring in things that require at least two frames of the movie, two locations, as we talked about last time, and they think they're talking about a single frame, what's in one frame. And there you have some examples like, plasma, ether, field, and energy, and so on. All those are dynamic concepts. Okay? They're not objects. They're not standalone physical objects. You cannot point to field, okay? Because field is something in motion. You cannot point to plasma. Plasma is something in motion. And I cannot point to ether because ether is vibrating, and so on. All these are dynamic concepts. You need at least two frames in the movie to conceptualize any of those. On the other hand, you have some static concepts that you can visualize and define and imagine in a single frame, and that's distance, location, and existence. And the one we're going to talk about today, which is direction. Okay, so what does the universal movie allow us to do? Identify the objects, define the static concepts, okay, and differentiate those static concepts from the dynamic ones. That's the purpose of the tool. It's just a tool. It's just a handy tool to be able to relate to what is static, what can be visualized in a single frame that does not require any kind of motion or time or whatever, any kind of movement. Okay, so what's the problem? Well, here it is. We consider direction a static concept. You can see it's under the static group, not under the dynamic group. Okay, but the establishment, the mathematicians, they believe that direction is a dynamic concept, and it's defined as a dynamic concept. And everybody has this notion, oh yeah, go in that direction. And the direction to get, what are the directions to get to City Hall? Well, you go this way and that way and that way and that way. That's how you get there. And so people have this notion that direction is the dynamic concept, when it's not. We put it under, in the universal movie, we put it under a static concept, a group of static concepts. And that's where the problem starts, okay? And it gets quite complicated here, okay? Okay, so here's the definition that you find out there. This is, I think, from the Wikipedia. And you look up orientation there, and it says direction is a synonym of orientation. Now, both orientation and direction sound like, static concepts. In fact, the first line that you'll read says something along the lines that says the orientation, and I put direction in there because it's a synonym, and it's also put in there as one of the possibilities, so I haven't cheated here. The direction of an object is part of the description of how it is placed, okay, in the space it occupies. So now they're talking about you standing in a given, location, and that sounds like a static concept so far. So far, so good. But then you'll see down the line, you'll see more specifically, it refers to the imaginary what? Rotation. Rotation that is needed to move the object from a reference placement to its current placement. Now they're talking about direction being something that moves, that has to do something with rotation. And there you see it's a rotation may not be enough to reach the current placement. It may be necessary to add an imaginary what? Translation, another dynamic concept, called the object's location or position. Well, how does translation relate to location or position when translation is a dynamic concept and location position by the mere words, they represent static concepts. And what they're referring to is ordered pairs there you see on the bottom right. That's what position is in mathematics. Okay, so ordered pair is how you get there. Okay, and you go 6 steps to the right and 4 to the north, and then you get to the position. And so they're talking about the translation, the fact that you moved from 0, 0 to 6, 4. Okay, so that's how it becomes a dynamic concept. And this is a synonym of orientation. Direction is a synonym of orientation. So under those definitions, they're dynamic. But then again, they come back to this, the location and orientation together fully describe how the object is placed in space. That's again, direction equals static concept. And then again, they say the orientation of an object does not change when it translates, and its location does not change when it rotates. And you can see the pictures they put in there, they all talk about motion. So what is direction? I thought we all knew what direction was, but these people are saying that direction has something to do with motion. It's a dynamic concept. So let's investigate further. And here you see some of the sites out there. Okay, and they talk about angular acceleration. And you see in those sites, it says direction of rotation, direction of motion. Well, what direction is the rotation in? I mean, in what direction if it's changing the direction constantly? So can we talk about the direction of a rotation, the direction of circular motion or irregular motion? That's not on a straight line. So what is this direction that they're talking about if the direction is constantly changing? And yeah, that's exactly what they're talking about. They're talking about a change in direction, not about direction. Okay, so change is a synonym of the word motion. And so yeah, when you say change of direction, you're talking about the motion of direction, of a changing, constantly changing direction. And the change has nothing to do with the word direction. That's the point. Okay, either direction is change or direction is direction. Static concept. But to say change in direction, we have a little bit of a problem there, because are we referring, when we use that word direction, are we referring to the static concept direction, or are we referring to the change? That's the issue. Okay, so we go to the Oxford Dictionary and see what they have to say. It says, world's leading dictionary publisher. So direction, a course along which someone or something moves. The course which must be taken in order to reach a destination. And a point to or from which a person or thing moves or faces. Faces I can accept, but moves, that's something else. Then you have the dictionary.com says the line along which anything lies, faces, moves with reference to the point or region toward which it is directed. Okay, so when you look at direct, because they use directed to define direction, which is already a no-no, you can't use a synonym. But you look at direct, it says to guide or show the way to a place. Direct, to point, aim, or what? Send toward a place or object. So in the best of cases, direction refers to a static and dynamic concept. In the worst of cases, it just refers to the dynamic concept, which is what most people have in the backs of their minds when they think about direction. Direction are kind of like the instructions on how to get there, like position, the ordered pair. It's how you get there. Okay, that's more or less the notion they have. And the other thing you should keep in mind is, in mathematics, they only deal with dynamic concepts. They don't have any use whatsoever for static concepts. That's where the problem begins. That's why mathematics became science, a synonym of science. And why science only describes, because that's all that mathematics can do, And what do they describe? Well, they always start the movie in motion already. It's already a film strip. They never start at square number one to point to the objects. You know, the Universal movie, a static frame. That's not what they point to. They can't, because mathematics has no use for that. That's the issue. And that's how, mathematics became a synonym of science and vice versa. Okay, so here we have a famous concept of mathematics that uses direction. Okay, let's find out what this is. It's called velocity. Okay, and it says speed and direction. Speed is magnitude. It's a quantitative concept. Direction, on the other hand, is a qualitative concept. So they're going to mix a qualitative concept that has nothing at all to do with mathematics, and they're going to blend it in there with speed, which is a magnitude, which is a quantitative concept. But we have more than a little problem here. We have a second problem here, because velocity is for a single point. So when you have a single point, what is the direction? Okay, here you have it. Okay, velocity is 5 miles per hour. Okay, we all understand that. What's the direction of that point? If it's a single point. I mean, if you have an elephant there, you say, well, okay, the trunk is pointed in that direction and it was moving in that direction. But when you have a single point, right, because velocity is only for a given point, okay, what's the direction? Okay, how can you conceptualize direction for a single point, meaning location? Okay, that's the first problem. Okay, and here you have the Earth going around the sun, okay? And they say, well, it travels at 30 kilometers per second around the sun. Okay, no problem. And they say, well, it's accelerating. And you say, hold it, I thought you just said that it's 30 kilometers per second. That doesn't seem like an acceleration. It sounds like a constant speed. Yeah, it's accelerating not because the magnitude, increased, but because the direction changes. The qualitative component of acceleration is what changed. Okay, and so here you see why we need to define this notion direction and realize that it has nothing to do whatsoever with mathematics. The direction part is the physics part. The magnitude, they can keep that. That's mathematics. But the direction part, that belongs to physics exclusively. Okay, and so yeah, you look at acceleration as a change in velocity and change in direction. And there you see the definition, okay? An object undergoing circular motion experiences centripetal acceleration, okay, towards the center, right? And in circular motion, centripetal acceleration refers to changes in the direction of the velocity, but not its magnitude. So we have the component known as direction right there at the bottom, okay? The qualitative part is what changes, and because that changes, they call it acceleration, which everybody and their mother, they usually relate acceleration as something that is increasing in speed. I accelerate. If you decelerate, well, you decrease your speed. So everybody thinks of speed because that's on a straight line. But when we have curves or a curvilinear path, now they look at direction. You can have a constant speed, but it's the direction that they say compels the acceleration. Okay, so this is what you got to keep in mind. Direction, now they're introducing something that does not belong in mathematics at all. Okay, and they call it acceleration, which acceleration seems to imply that they're referring to an increase in speed, deceleration being the decrease in speed. Okay, so keep all that in mind. Okay, but then we run into some other types of problems. Here's one of them. Okay, Stephen Hawking, a guy who died a few years ago, says, goes in there, I'm not going to read all this. He says, in other words, the laws are the same in the forward and backward directions of time. Forward and backward directions of time? What direction is that? I mean, I guess my forward direction is this way, right? But you're coming in opposite direction. So which way is time going? Is it going in my direction, my forward, or your forward? So they use these terms, forward direction of time, and people just swallow it. They don't catch these things. They just goes through one ear and out the other. And yeah, we have a problem there because these people are talking about the flow of time and that you go forward in time. And it gets worse. Here you have Mr. Brian Greene, and he says he goes forward to the future. Okay, he travels to the future. Okay, so time always goes towards the future for some reason, And they talk about whether, they do all kinds of analysis in the religion of mathematics about time, whether, it flows in the reverse direction and so on down the line, And they talk about flying to the past or going to the past, say, kill your grandfather, that kind of thing, So we get to all this language stuff. It's all related to language. Some of this language does not belong in mathematics at all. Some does not belong in physics. Like time does not belong in physics at all. We have no use for time, okay? Because in physics we have to explain, and time can only describe. We have no use for time. It doesn't explain anything. I cannot explain anything by saying that the pencil, fell to the floor in so much time. Okay, that's a description. I need to know what caused it. That's what physics is about, not how fast that thing moved. Okay, so what do? Well, in science and physics, we have to start with language, what people call semantics, word salad, word wizardry. No, it's called, or semantics, these terms that they use to brush aside all this because it bothers them. They want to use the word field. They want to use the word plasma. They use electricity as a physical object. Just stick your fingers into the outlet and you'll find out if it's an object. So that's how they determine if it's an object. They touch electricity, it gets a shock, and they say, oh, that was an object. That was the thing that hit me. Okay, so we start with language. Okay, here it is. Language of physics. That's what we're going to do. We're going to learn some language of physics that we need to especially define what direction is. And so in science, we do not do experiments, we do not use math, and we do not make predictions. Why? Because science is about explaining rationally. That's what science is. Science, we explain. That's all we do. Okay? Objectively, like we said the other day, okay, we have to give an objective explanation for the purposes of physics, right? Of a mechanism, of a cause. Do you believe it? We don't care, because belief has no role in science. I'm not here to convince you. I'm not here to persuade and convert you. I'm here to explain a mechanism so that you understand it. Then you go on your merry way and think whatever you want. You just need to know or understand what I'm trying to convey to you. My theory of what I think the mechanism is of gravity, of magnetism, of electricity, or whatever. So I explained to you a mechanism, you understood it, that's the end of science. Whether you believe it or not, whether I like it or not, that's irrelevant. In science, that's religion, that's belief, opinion. Okay? So, physics, rational explanations of causes and mechanisms. That's what physics is about. What the mathematicians dismiss as philosophy, because they cannot explain. That's why they dismissed it and got it out of science. And so today they say, well, that's not science, that's philosophy. Go to the philosophers. You go to the philosophers, they send you right back. They say, well, we get our cues from the mathematical physicists. And so whatever they teach us, that's what we analyze. So you go to the philosophy, like you go to the Stanford Encyclopedia of Philosophy, and they talk about the same exact nonsense that the so-called physicists, quotations on that, mathematical physicists, what they talk about. So no one's rational. Whether you go one side of the campus or the other, they're all irrational. Okay, so what, if you're going to explain a mechanism, you're going to need objects, okay? And the most basic of words in physics is the word object. Thing, body, entity, figure, whatever you want to call it. Those are all synonyms, okay? We use the word object. What is object? That which has shape. People say, oh, Bill, please define shape for me. No, we don't want to define shape. Sorry. Say, well, I got you there. No, we don't define shape because it means that you didn't understand squat of what the problem is. The problem is not the word shape. The problem is that if we do not have that definition there, we're going to go with a default. And the default is see, touch. That an object is that which you can see or touch. And if you go with see or touch, those are verbs. Verbs require two locations of an object. And so it's already, so you can't use those, you can't use a verb to define the word object. Okay, so and besides the fact that you need two objects to do see or touch anyways, it's got to be something that sees or touches something else. So there are many problems with the see-touch criteria, which is the one everybody uses because everybody wants to go and do an experiment in the lab to see and touch that which is invisible and intangible. So we don't know how they're going to accomplish that with any experiment. That's why experiments are not part of science. You can do all the experiments you want, no problem. But when you come to the conference, we want an explanation, not your stupid experiment. Okay, so see-touch is the criteria if we do not go with shape. That's the issue. We don't have to define shape. We just have to know the difference between shape and see and touch. That's it. Okay, or any of the other, some people say it's that which has mass, volume, whatever, same thing. You got to know the difference between shape and all the others. As long as you know the difference, we do not need to define the word shape. Okay, besides, the devil's advocate, he's gonna just go, and show you that you need more and more words to define the previous word and the previous word and the previous word. And that's what they want. They want you to go through the whole dictionary. Okay, and just to show you that, see, eventually you cannot define a word perfectly. That's their argument. No, in science we have to. In physics, we cannot leave the conference room. There's 8 billion people here in this conference room. We cannot leave. The doors are shut until we define the word object, because we cannot do physics without understanding what an object is. Okay, what the word object, what the definition of that word is. So we go with the word shape, and that goes against see and touch. In other words, against experiments. We don't do experiments to see or touch that which is invisible or intangible, and hopefully there are invisible, intangible objects out there mediating gravity, magnetism, because otherwise you're doing your explanation with black magic. You're saying there's action at a distance. Yeah, by what? Angels, God, black magic? That's the issue. So object and shape, they're static concepts, both of them. And math and math phys, they don't use objects, okay? And they don't use static concepts. They have no use for static concepts. All of mathematics and all of mathematical physics deals with dynamic concepts only, exclusively, okay? Okay, let me get this one out of here. So here, let's go with one static object, an object that we're going to need to define direction, and it's the word line, okay? What is line? Well, line is an object. It's a figure. And there, you can see it's got shape. It's that blue one, violetish one there, okay? It's an elongated rectangle. That's what a line is, okay? And that's objectively what's in front of your eyes, okay? So what do you see there? You see some kind of elongated rectangle? That's a line. We call that a line, okay? How many dimensions does it have? 2. It's got width and height. You can see that. I took a little piece of it and expanded it. You can see it's got height and width, and it's got 4 edges. I show 3 there, one on the top, one on the, my right-hand side, okay? And one on the bottom. And you should imagine on the other side of this stick, right, the 2D stick, there's another straight line, another edge. So we have 4 edges. The line is straight, and so are the edges. Okay, and we're going to get to that in a second. And the line is continuous. Okay, what is continuous? Made of a single piece, conceptually made of a single piece. Okay, it's not made of parts, not made of little pieces. It's not mereology. It's made out of a single piece. It's continuous. Okay, and it's finite. Like any stick, like this one, more or less. It has a beginning and an end. Otherwise, it would not be an object. On the other hand, you can see the line of mathematics. It's the infinite line, and that's not an object. That's an itinerary. Okay, it's made of points. And what are points? Locations. So they're talking about an itinerary. And it goes from negative infinity to positive infinity, because they're really trying to put numbers in there. And they say each one of those points is a number. Well, aren't there are there more numbers between any 2 numbers? Yeah, put as many as you want. We can put infinite numbers between those as well. Chop it up as many pieces as you want. Okay. So we're talking about not lines. We're not talking about a stick that belongs to physics. We're talking about an itinerary, and again, it's not an object. Okay, an object is a line. The line is the one that you see on the top, not the one you see at the bottom. Okay, so let's make sure we understand that. Okay, let's move on here, and here we have some definitions that we're going to need. First one is the basic concepts used in physics. The first one is straight. What do we mean by straight? Well, straight, first of all, is an adjective. And it is a synonym, essentially, of direction. In other words, it's the adjective version of direction. Okay? But straight is an adjective, whereas direction is not. Okay? In common usage, in ordinary speech, direction is a noun. It is not so in physics, because only objects can be nouns in physics. You cannot talk about direction per se in physics, like saying the direction did this or direction did that. You cannot use it in those terms. It cannot be the subject of a sentence in physics where you're explaining a mechanism. Okay, but it's a property, it's an attribute. You have attributes like shape, which are intrinsic, and you have attributes like direction, which are extrinsic, which involve other objects. Okay, so we don't have a word for that, because no one ever figured this out. That's why. Okay, so straight is an adjective, and it's used to qualify objects. All adjectives are used to qualify things, objects, okay? Entities, figures, okay? Straight edge, what is that? Well, it's conceptually 1D. Conceptually, I underline conceptually or highlight conceptually, because edge is not a physical thing, okay? So you cannot say it's got, that the edge is a thing. What the edge is a concept that serves as kind of like a limit to a thing, okay? So it's a conceptual, but it's conceptually 1D. Objects can be 1D, 2D, 3D, well, not 1D, but 2D, 3D, but edge cannot be any D, okay? No dimensions can be applied to edge. But it's conceptually 1D. I hope you understand what I just said. It's kind of like the line of mathematics. Okay? Straight edge, again, you could say it's the synonym of width. Okay, in that sense, you could say it's a dimension. I'm going to use the word edge for straight edge from now on. So anytime I say edge, I'm referring to a straight edge. It's continuous also. What is continuous? Made out of a single piece. Not the edge of your balcony. That's not made out of a single piece. Okay, I'm talking about the edge that we're going to use in physics when we point to an object. Whatever edge, whether it's straight or curved, that edge is conceptually made of a single piece. Okay, it's like the object itself. The object is made of a single piece. We don't care how many atoms make it, or if it's made of points or any of that. Mereology doesn't play a role in science. That's nonsense invented by the philosophers, so-called philosophers. Okay, and continuous is opposite of segmented. Segmented means chopped into pieces. Okay, and you can maybe relate those people who do some electronics or maybe even programming. You know, you have their analog versus digital. That's more or less the notion that we have there. Okay, segmented means made of parts. On the other hand, we have axis. An axis is a concept. It's not an object. Okay, it's not a stick really, but it's a concept that's not equal to edge. Okay, so edge, axis, and direction are not synonyms, because they're used for different things, okay? And the notions we have behind these words. Edge has to do with the limit of an object, a border kind of thing, right? Whereas the axis is, you know, around an imaginary stick. You can place a line in there if you want, because that's also properly visualized. But the issue is that it's a rotation place, a place around which something rotates or spins. Okay, so we use these things for different things. We don't use the edge for that. Okay, sometimes the edge could coincide with an axis, but not necessarily so. Okay, so these are the notions that we need to learn in order to zero in on our definition of direction. So it wasn't such an easy concept to understand, especially when the mathematician thinks that's something in motion. Okay, so these are the most popular notions that we have today of what a direction is. The course along which something moves, aims, or points, a line leading to a place or point, or along which something lies, aims, or points. Okay, to aim or move along a line, a position to which motion or another position is referred, and the alignment of 2 points in space, or their mutual angular position or orientation. These are the general notions we might have out there. And why do I mention these? Because from there we are going to try to see if we can extract the main notions that we're going to need to define this difficult word called direction. Now, I just want to point out something that people say, well, direction, that's so simple. Why haven't we zeroed in on this? Why haven't we zeroed in on the word object, another simple word? Why haven't we zeroed in on the word exist, another simple word? And I'll tell you why. Because it's the simple words which are the hardest to define, the ones that form your foundation. Okay, that's why. Okay, and aside from the fact that we have the wrong people doing it, which are the mathematicians, which have no use for static concepts. Okay, so all these things you got to keep in mind. Okay, so here's what we might need to define direction, and it's 2 objects. You need 2 objects to define direction. And the fact that you need 2 objects, remember what a concept is? It's a word that invokes 2 objects or 2 concepts, or 1 concept and an object, treated as if it were an object. Okay, so you need 2 things, and that's what a concept is. So in that sense, direction is a concept. You need 2. Facing, you have 2 objects, and like my finger, okay, and you say, well, here's a surface, right? And whatever I point to, the moon, a stick, a tree, a rock, whatever I point to, that's got a surface. And so there's a face of that thing facing me and my finger facing it, and we establish some relation there, and we call that direction. So we need facing, or the notion of facing is involved in there. Okay, aim, we have to aim, right? Before you point, you got to aim, or pointing is aiming. You could say it's got to be straight, not rectilinear. See, some people use the word rectilinear. Rectilinear is what we use for motion, right? And we say rectilinearly, something is moving rectilinearly, parallel to a straight line. Physics, straight. Rectilinearly, well, that's also physics. You're going to talk about curved motion versus straight motion, right? And so rectilinearly, you could say parallel to straight motion. But what all these people use is straight path, straight motion, straight itinerary. No, the word is rectilinear. Okay, you can't use the word straight. You can only use it for objects, not to qualify verbs, not in physics. In ordinary speech you can, in mathematics you can, not in physics. Continuous, single piece. It's got to be continuous. You can't chop direction into two pieces or into several pieces like the mathematicians do. You know, they have this dotted line, infinite line made of points. It's all chopped into points, locations, right? And they say that's a line, and that line, that one that I just defined, is direction. No, because that's an itinerary. Okay, we don't use itineraries to define direction because nothing is moving. Okay, and here you have the definition. Okay, direction, a line between two objects. What was a line? It was what the mathematicians call line segment, but it's not even that because this line is not 1D. Okay, it's 2D. Okay, and that's what we have in direction. Because we can visualize a line, we cannot visualize a 1D, whatever the mathematicians call a line. Okay, you can also say that direction is a straight edge. Okay, if you're going to use that as more or less a synonym. There's two others I sometimes use. I'm not too confident of those, but I'll put them there anyways. Mutual facing of two objects, and direction, also line of sight. The problem I've got, especially with that last one, is that line of sight. People say, oh, you use sight, a verb, seeing. Okay, but yeah, we're talking about line of sight. So again, you can use any of these. The idea is to get the notion inside your head of what the definition is. You can use any of those definitions to a certain degree, depending on the context. Okay, so what are the conclusions? Here they are, conclusion or of direction. Okay, static concept. Okay, first of all, it's not a dynamic concept. It's qualitative. Okay, doesn't belong in math. Only quantitative concepts belong in math. Okay, continuous. It's made out of a single piece. Okay, it's straight. You could maybe replace it with an edge or an axis. Make sure you are very much aware of the context there. Okay, if you're going to use the edge of something to say, okay, that's my line of sight, that's my direction. Okay, be aware of what edge, the context of edge and axis. Okay, straight. Yeah, it's got to be straight. Okay, distance. It's essentially distance with an arrow. Remember what distance was? Separation between two objects. And you maybe illustrate that with a line, two-dimensional line, right? Segment. Okay, not a 1D line, it's a 2D line. Okay, that's all you can see. Okay, and we put a stick there, we call it a line. And if you put an arrow, well, that's direction. Okay, see how simple it was? And it requires two objects. They have to be, facing, one face versus the other face. In that sense, face facing face, face against face, face opposite face. And no direction between concepts. You cannot say, well, I'm moving in the direction of intelligence or of love. No, there is no direction between love and intelligence. Okay? So when people say time moves in a certain direction or forward or whatever, or you have counterclockwise or clockwise direction, no, you got to point to something, and then you have direction. And you can't point to something if you're turning the corner. Okay, then you're not pointing to that same something. Okay, so you cannot say that a curvilinear itinerary goes in a given direction. It doesn't. In fact, it's changing its direction every location, and that's what they call velocity at each one of those points. And the whole thing is called acceleration if direction changes. So that's something for you to sink their teeth in now.